Hey, math friends. So our learning target today is I can problem solve proportion word problems. Now within that will be the things that we've been working on, like tax and tip and percentages. So everything kind of overlapping in our work today. So let's talk with this idea of percentage. So 68% is 68 out of 100. I probably should have read the question first. Sorry, I already knew what the question was. So a quarterback completed 68% of his passes in a game. So that means if he threw the ball 100 times, 68 of the times there was a completion, there was a catch made. Now, is it always that they always throw exactly 100? No. So we have to adjust to that. So if he threw 25 rather, the question is how many catches were made or how many completions were made out of the 25. Cross products and solve to solve that. And you can also see it's division by 4, which isn't super easy to do in your head. So just a review today. So we're looking for how many times did the quarterback complete the pass if the pass was made 25 times. So you should come up with that there was a completion 17 out of the 25 passes that were made. So there's our first word problem that has a percent involved in it. All right, I'm going to pause the video quick and change pen. Okay, so for the next question, for a survey, a company decided to call 7 out of every 5,000 people. So you're hearing that out of there, 7 out of 5,000. Ooh, this pen works so nice. It's so exciting. So they called for a survey 7 out of 5,000. Is it possible for them to call all 5,000 people? Probably not. So we would just say that that's really a sample of the population. So how many people should be called out of town of 78,000 people? So if we use the same proportion, how many out of 78,000, here's that of, how many people should we call? I'm lacking space there, so I'm not going to show all my steps. So go ahead and take cross products and solve those. We're looking for how many people should we call to keep that same rate. And I'm coming up with 109.2 people. Now just processing that for a minute, is it possible to call 0.2 people? Not really. We can't really call a fraction of people. So we're going to just estimate that as that we should estimate to call 109 people. So everything we're going to do today is a word problem. Everything we're going to do today is under the category of a proportion. Even if there's an easier way to solve it, according to Minnesota State standards, I need to be able to check the box to say that you know how to solve proportions in a variety of situations. Cool. So next problem, I think, yeah, we'll do this one. At Paul Bunyan's logging camp, the cook scrambled 20 eggs for every 3 loggers. So we have eggs and we have loggers. Oh, this is not a percent question. That's okay. So 20 eggs for 3 loggers. How many eggs did he need for the 288 loggers at camp? So if we have 288 loggers, how many eggs? Taking cross products and solving here, we get 3x is equal to 20 times 288. We're going to divide by 3, copy, paste, copy, paste. So we're left with that we would come up with 1,920 eggs. I recognize that that might be really fast. You just need to pause the video. Otherwise, the video is going to be 10 years long. So we would say that for 288 loggers, we need 1,920 eggs for 288 loggers. That would be the relationship that we're looking for there. So again, pause video if it go too fast. Now I'd like you to try the next one. It is a percent question. Try it, try it, try it. All right, you should have tried that question. It says if you answer 14 questions correctly on a 15-question quiz, ooh, that's pretty good. What percent did you receive? What percent? So if the quiz was out of 100, that would be super easy for us, but the quiz is out of 15. So we got to convert to 100 and figure out your percentage because it's the definition. Taking cross products to solve, we get, I'm out of space here. We get 15x equals 1,400 Divide both sides by 15. Copy, paste, boom. And what do we get for a percentage? We're looking for your grade here on the quiz. So you were asked to already do that. I'm going to round to the nearest whole. I'm going to get rid of the decimal. It's 93%, which means you would have scored an A. You probably assumed that, but that's just a good check in there to make sure that you were good with that. All right. Next question. I'm going to search for percent questions out of these word problems. Otherwise, we'll be here for 10 years, although there's some good ones in here. Yeah. I don't have a ton of percent ones, do I, for you? Here, well, let's do this one. There are 8 previews before a movie. You know those yucky old previews that take forever. 75% of the previews are for comedy. So we're saying 75%. Boom, there's our percentage. Are comedies of 100. Okay, so were all of them comedies? No, 75% of them were. And we are told in the very beginning that we watched 8 previews. So how many out of the 8 previews were for comedies? So how many comedies out of the 8 previews? That's really the question for this. Taking cross products and solving. Do it. How many for comedies? As you solve, you should have found out that 6 of the previews were comedies out of 8, which means 2 were not comedies. Sweet. Okay, next problem is a percent of change, which we just got done doing. So I'd like you to try this problem on percent of change. See how you do. Pause the video, give it a shot, and then come back and check to see how you did. All right, you should have unpaused your video. Back in the day, we used to pay for text messages. Most people have unlimited now. Maybe some of you still have to pay. But text messages, there was a change that occurred. And if we take the change that occurred, it was at 10 cents and it increased to 25 cents. So that is a change, an increase of 15 cents. So our change is 15 cents increase in text cost per text message. The original price was 10 cents. So what percent did we increase in cost for text messages if the change was 15 and the original price was 10? Taking cross products and solving, you tried it. You should have come up with 150% increase in price per text message. So you all were asked to solve that. That might have panicked you a little bit of how did we get greater than 100? The only time we can get greater than 100 is when there is a percent of change happening. So that's a great example on that. I don't think we have any other percent questions, but I do think I'm going to cover one of these. Ooh, that was a good one, I think. Yay! I don't still want to do all these today. Otherwise, the video would be too long. Let's do this one. The number of riders on the bus last year was 52. The number of the riders on the bus this year is 72. So if we look at the change that's happening, we're talking about an increase of bus riders of 20. So we have an increase of 20 riders. The original amount of riders happened last year. It's 52. If we take percent, we take cross products and solve here. We want to know what is the percent that the bus riders increased over time. And you often hear stats people say that where we have a X number of percent increase. As we solve this bus rider situation, we are able to say, if we round, that we have a 38, or you could say 39%, I'll accept either, kind of in the middle of both of those, 38% increase in bus riders from last year to this year is called percent of change. And isn't there one more percent? This one right here. Jane had 121 hits out of 365 at-bats. I'd like you to go ahead and try to solve this problem about Jane's baseball stats. All right, guys, let's try it. Come on, make sure you're trying these. This is super important. This is your future, right? 121 out of 365. What percent? We need to make that out of 100. It's not out of 100 right now, so we got to make it out of 100. We take cross products to solve. We want to know what percent batting. So that means 33% of the time Jane gets on base with an actual hit. Just because you get on base doesn't mean it's statistically a hit. There could be an error made, or you could have forced somebody out. So, yay! And we're going to do one more that is not percent related because I think it's just a good reminder of how to do that. It's this question. So this is not a percent question, but it is an excellent idea of how we use a proportion super easily in our table. So our conversion right here is given to us that we have inches compared to centimeters. Boom. Awesome. 1 inch is the same as 2.54 centimeters given. That happens a lot where we're given the conversion. So how many inches in 8 centimeters? So we're going to put the centimeters right here. We want to know simply through using cross products how many inches. So we get 2.54x equals 8. I loved this pen for a minute, not loving it anymore. Divide by 2.54, take cross products, boom. So we get 8 divided by 2.54. And we end up getting I'm going to round to the hundredths here. 3.15 inches is the equivalent measurement. So we're asked in the original question, how many inches is 8 centimeters? How many inches is 8 centimeters? We would say it's 3.15 inches, simply by using a t-table cross products. So our first summary for today basically is we just need to be able to set up any sort of proportional situation. If it's a percent, there's some sort of 100 involved in it. If the percent is given, then we just drop that 58 in. But if the percent is unknown, we don't. We have our part here, and we have our of here, our total. So that's our percent stuff, and anything else is just a nice little t-table with information going in. All right, so I can problem solve word problems that have proportions in them. That's our units. Find proportion and percent. I did proportions in unit 5. We're doing percent now in unit 6. They overlap in a lot of the skills. Have a glorious night. Woo!